Hello there. Thank you for tuning into my randomized block experiment presentation. We must ask ourselves the question, what is a randomized block design? Our first step is taking the sample subjects, also known as the population, and breaking them up into a subgroup based on certain variables. In this case, it would be the A block and the B block, hence giving the name randomized block. Those two blocks are then further split up into different variables based on a process that they undergo. They will undergo a random process and be split up into three different groups, each on A block and B block, hence giving 6 different subgroups. After you collected all the data from the 3 methods of the A block and all the data from the 3 methods of the B block, you take the results and you compare how the results in the A block were influenced by the 3 methods and the results in the B block were influenced by the 3 methods. Then you compare it all and bring it all back together and analyze the results. We now make our way to the strengths and weaknesses of randomized block design. Among the strengths of a randomized block is that it allows you to analyze multiple factors within a population that may be influencing a certain variable. And it also allows us to use large crowds to get the most information out of it, which is very good. So let's say you have this population. You can break it up into 2 small groups based on a certain variable. To make matters better, you can break those 2 small groups into even smaller groups based on another variable. This allows you to take one population and divide it up into essentially 2 different variables, which then allows you to gather information on how those variables influence the population as a whole. One of the downsides to it is, like all other statistics, it cannot be generalized to in every situation, as the randomized block can be very specific in many aspects. Now we get to the engineering application. As an industrial engineer, I figured you could use this with workers in a factory. You take the workers in a factory and you split them up into the morning shift and the night shift. Then you take the ones who work in the morning shift and the night shift and you split them up into assembly method 1 and assembly method 2. You take the results from both different instances and then you compare them. If the workers in the morning worked better than the workers at night, then you know that the morning is more efficient. If assembly method 1 worked better in the morning, then you use assembly method 1 in the morning. If assembly method 2 worked better at night, then you would choose to do that at night. Essentially just looking for the most efficient way to handle things. Here are my sources.